Yes, hello, Shriharsha.
Yes, ma'am.
Okay, which question we were doing yesterday? 8.4, right?
Yes, ma'am.
Okay, so how many questions we covered? I think
Ma'am, 2.
2 questions. Okay, let's start with the third one now.
Ma'am, about the test, would you discuss the answers?
Others are, can we do it in the next class? Actually, I just want to finish the chapter first of all.
Okay, ma'am.
Yeah, it will be an interruption and then I'll be discussing the test. So it will be a revision of coordinate geometry as well. Okay. Yes, Hamna, can you hear me now? Anyway, exercise 8.4 we are doing. Question number 3 today. Now, first question is this, that sine square of 63 degree plus sine square of 27 degree and divided by cos square of 17 degree plus cos square of 73 degree. Now you have to simplify this. Yes, Rida, can you hear me?
Yes, ma'am.
Okay. Right. So you have to simplify this thing now. Now, first thing is we try to make the angle
Ma'am,
same.
exercise 8.4.
Yeah, this is 8.4, right?
No, ma'am, this is 8.3.
No, it's 8.4. Look at the question in NCRT. Huh. Sure.
Ma'am, it's proof, ma'am, 8.4.
I'm sorry, what you are saying, I didn't get.
Ma'am, in 8.4, the 5th question is proof, ma'am.
Fifth question. No, but I'm doing the third one. You said we covered only 2
Ma'am,
questions.
5th question, second, but sorry, ma'am.
Okay, fifth question we are supposed to do. All right. Right, fifth question. Prove the following identities where the angles involved are acute angles for which the
Ma'am,
expressions.
in this we did 2.
First part we have done.
Ma'am, second also.
Second also we have done. Let's do the third part. Tan of theta divided by 1 minus of cot of theta and then plus cot of theta divided by 1 minus of tan of theta. Okay. And then you have to prove it 1 plus sec of theta into cosec of theta, right? So as I told you, the first thing is to convert everything in sine and cos. So that means make things simpler. Let's take the LHS. And I'm directly converting in sine and cos. So tan theta will be sine theta divided by cos theta. Yes, Rida? Okay. 1 minus. Now cot will be cos theta divided by sine theta. Just inverse of tan plus. Cot is cos theta divided by sine theta. And then 1 minus. And then you have sine of theta divided by cos of theta. Correct? Okay. Now, okay, let us simplify it. Sine theta divided by cos theta. And here, now you take LCM sine theta, right? And then you have sine theta minus of cos theta. Is that okay, Hamna?
Yes, ma'am.
Okay, cos theta upon sine theta. And then again you take LCM here. LCM will be cos theta. So it will become cos theta minus of sine theta. Yes, any confusion? Right. So you multiply it like this, sine theta will go in the denominator. It will become numerator sine square theta. And then you have cos theta into sine theta minus of cos theta. Is this okay?
Yes, ma'am.
Yes, Harsha, fine. Right.
Yes.
Similarly, this cos will go in the numerator, cos square theta, and then you get sine theta into cos theta minus of sine theta, right? Okay. Cos theta minus sine theta, yes. You can do one thing. If you want to take LCM, before that you can do, see, this is sine theta minus cos theta. So you can take a minus sign common from here so that it becomes same in the denominator. Yes. So I take it like sine square theta divided by cos theta into sine theta minus of cos theta, right? Now I take the minus sign common. So this plus minus will actually become minus. Yes. Cos square theta and divided by, so that becomes sine theta into, now the minus term will become plus and the plus term will become minus. Is that okay with everyone?
Yes, ma'am.
Okay. Now I have two fractions. Again, you take LCM. So the LCM this time will be, sorry, it will be sine theta into cos theta into sine theta minus of cos theta, correct? Okay. So this will be a sine of cube theta in the numerator this time and minus of sine, it's already there. So cos of cube theta I'm getting. Okay. Any confusion here?
No, ma'am.
Okay. Right. Now sine a cube minus b cube. What is the formula of this thing? A plus b whole cube, right? This is actually equal to a cube plus b cube plus 3ab into a minus b. All right. No, actually I need a cube minus b cube.
Ma'am, I have a doubt about the signs.
Yes,
Ma'am, how
say.
will both be minus?
Both means where, Harsha?
Ma'am, minus cos square theta and sine theta. On the second term.
Here,
Yes, ma'am.
this minus is actually coming from here. Okay, let's see here. I have a plus, right? Okay, I'm just explaining this term, only this one. So if I take a minus sign common, it will become cos square theta divided by sine theta, right? And I take a minus outside. So this will become minus of cos theta and plus of sine theta. All right.
Yes, ma'am.
Yes. So this minus, when it will combine with this plus, it will become minus plus minus.
Yes, ma'am.
Yes. So that is why I'm getting a minus here. Correct. And
Okay.
I have just flipped it. I have written like sine theta first and then minus of cos theta.
Okay, ma'am.
Just to make it look similar to this one. That's it.
Okay.
Yes, Rida, any confusion, Hamna, at this point?
No, ma'am.
Yes.
No, ma'am.
Okay. It's all like mathematical calculation. So if you sit and do it like carefully, so you will get it. Anyway, I'm getting, for example, a cube minus b cube in the numerator. What can I do here now? I have a formula, right? A cube minus b cube is actually equal to a minus b into a square plus b square plus ab.
Yes, ma'am.
If you remember, all of you.
Yes, ma'am.
So you have to use this identity now. So this sine cube theta minus cos cube theta can be written as a minus b. That means sine theta minus of cos theta, right? Into a square. That means sine square theta plus b square. That means cos square theta and plus sine theta into cos theta. All right. And then your denominator is here. So sine theta cos theta into sine theta minus of cos theta, right? Okay, so I'm just removing the identity. I hope you have written. Okay. Now you can see this term, this is same, right? Sine theta minus cos theta, sine theta minus cos theta, correct?
Yes, ma'am.
Okay. Now this sine square theta plus cos square theta will become 1, and then 1 plus sine theta cos theta, right? And then in the denominator, I have sine theta cos theta. Now just, break it. So 1 upon sine theta cos theta, right? And then plus sine theta cos theta divided by sine theta cos theta, right? Okay, I don't have space. Can I rub a bit from here?
Yes, ma'am.
Okay. Right. So this term, this 1 upon sine theta into cos theta. So 1 upon sine can be written as, like, I can simply break it 1 upon sine into 1 upon cos this time, and then plus 1, right? Now 1 upon sine is your cosec theta, and 1 upon cos is your sec theta, and plus 1. This is equal to RHS. Done? Okay, let's take the fourth part now. Okay, if anyone who has not written, they can tell me.
Ma'am, can you scroll up once?
Okay.
Done, ma'am.
Okay, Rida, have you done?
Yes, ma'am.
Okay, fourth part. Now this is 1 plus sec of A divided by sec of A. This is equal to sine square A divided by 1 minus of cos A. Okay, so this you have to prove. Now here you see the RHS itself is looking a bit complicated. So first of all, we simplify the RHS and then we will try to match it with the LHS. So let us simplify my RHS now. So this is sine square A divided by 1 minus of cos A. Whenever you can see square with sine or cos, you can simply use the identity, right? Sine square A plus cos square is equal to 1. So sine square A can be written as 1 minus of cos square A, right? From the identity. And then you have 1 minus of cos A, correct? Now 1 can be written as 1 square. So it's A square minus B square. So this can be written as 1 plus cos A into 1 minus of cos A. And then I have 1 minus of cos A, right? So this term will get cancelled out. So I'm left with 1 plus cos A only. So it looks a bit simplified now. Now come to LHS. Now for 1 plus sec A divided by sec A. So convert it into cos. So 1 plus Or you simply just break the denominator first of all, 1 upon sec A plus sec A by sec A, right? 1 upon sec is cos A and plus 1. So this is the same as your RHS.
Done, ma'am.
Okay. Right. Let us take the next one. Fifth part now. So it says cos of A minus of sine of A plus 1 and then divided by cos of A plus sine of A minus 1 is equal to cosec of A plus cot of A, right? It is also given that using the identity cos square, cosec square A is equal to 1 plus cot square A. Okay. So you have to use this identity that 1 plus cot square A is equal to cosec square A, right? So basically for using this identity, I require cot somewhere, correct? Yes?
Yes, ma'am.
Okay. So if I require cot, so what can I do in my LHS is that I have, for example, cos A, right? If I divide this cos A by sine A, it will become cot. So I thoroughly divide everything by sine A. No problem. So that I'll get cot, correct? And then same here, sorry, cos of A divided by sine of A plus sine of A divided by sine of A minus 1 upon sine of A. Any problem?
No, ma'am.
Okay, I've divided numerator and denominator by sine A. So this first term becomes cot of A and then minus 1 and plus 1 by sine A becomes cosec A divided by, again I get cot of A plus 1 and minus of cosec of A, right? Okay. Now what can I see here? So let us use this identity. For example, I can replace this cosec A, right? Or I can also do one thing here. I can replace this 1, right? So 1 will become your uh, cosec square A minus of cot square A. Yes, from this identity.
Yes, ma'am.
Okay, so I can substitute this 1 like this. So cot of A minus, now put a bracket when you have minus outside. So this becomes your cosec square A minus of cot square A and plus of cosec A. And similarly in the denominator, you get cot of A plus then cosec square A minus of cot square A and then minus of cosec A. So let me see what I'm getting. I don't know. So now this becomes, open the bracket. So cot A minus of cosec square A, then minus minus plus cot square A, and then plus of cosec A. And in the denominator, I'm getting cot A plus cosec square A minus of cot square A minus of cosec A. Will it solve any purpose?
Ma'am, it would be the same, right?
Hmm. Okay, let me do one thing. Let us not replace the denominator. Just keep 1 in the denominator. And let's keep the denominator same, only numerator we are trying to replace. So I have 1 here, right? And similarly plus 1 and then minus of cosec of A I have here, right? Okay. Hmm. Let's do it like this. Okay, up till here is fine. Now you do it like this. Yeah, any confusion so far?
No, ma'am.
I have simply replaced the 1 in the numerator by the identity. That's it. Okay. Now I solve it like this. Let me just try. So this is cot of A and plus cosec of A I'm writing like combined. Okay. And minus. Then I have this bracket cosec square A minus cot square A, right? And then in numerator, I have this cot A plus 1 and minus of cosec of A, correct? Hmm. I'm sort of stuck in this question. Oh, see, I can do it like this. Just a minute. Let me take it again. Let us try to attempt it again.
Ma'am, we can use the identity a square minus b square, right?
Yeah, but that's what I'm also trying to use. But let me just put it this way. First of all, if I write it like this, cot A and plus of cosec A, right? And divided by mm, now this one, which is in minus, this can be written like this. I think cosec square A minus of cot square A. Any problem here? And then in the denominator will remain same. Yes, Rida, any problem? Now let us try to open this bracket. So this is a square minus b square. So this will become cot of a plus cosec of a minus. So this will be cosec of a plus of cot a into cosec of a minus of cot a. Correct? And then the denominator. Cot of a plus 1 minus of cosec of a. Correct? Okay. What will it give me? Now I can do one thing from the both the terms. Let us try to make, see this. This is one term and this is the second term. Now both terms are having cosec a plus cot a. So I can take cosec a plus cot a common from here.
Yes, ma'am.
Yes. So let me take this cot a plus of cosec a common, right? So from the first term, like here, I'll be left with 1 and then minus. So this term I have already taken common. So I'm only left with this cosec of a and minus of cot a. So be careful with the sign. So always use brackets. And then the denominator. Cot of a plus 1 and minus of cosec of a, right? Now you open the brackets in the numerator. So cot of a plus of cosec of a, and this becomes 1 minus of cosec of a and minus minus plus cot of a, right? And then you have cot of a plus 1 and minus of cosec of a. Now you can see this term is same as this, like this complete bracket. Yes, so this like complete bracket will actually cancel out. And you are only left with cot a plus of cosec of a, which is your RHS. Yes, Harsha, any confusion?
No, ma'am.
Okay. Okay, next.
Ma'am, 1 minute.
Okay. Yes, Rida, any confusion to you? Hamna?
No, no confusion.
Okay, so I'm erasing a little bit from here. So whenever you have under root, so in the denominator, so the first step is to rationalize it, right? We try to remove the under root. So we will rationalize it. So the LHS I'm taking, this is under root 1 plus of sine A divided by 1 minus of sine A. So just multiply it, under root 1 plus sine A divided by 1 plus sine A, right? Same number I'm dividing and multiplying. So in the numerator, I'm 1 plus of sine A, correct? Because square root multiply, it will gone. And the denominator will be like under root, right? 1 minus sine A into 1 plus sine A. So that way I can write it. So it will becomes 1 minus of sine square A. Correct, Rida?
Yes, ma'am.
Harsha, any confusion here?
No, ma'am.
So 1 plus of sine A divided by under root. Now 1 minus sine square A is cos square A. So it becomes 1 plus of sine A, and under root will now go on. It will be only cos A. And then you break it. So 1 upon cos A plus sine A divided by cos A. So 1 upon cos A is your sec A, and this becomes your tan of A, which is your RHS.
Can you explain the rationalizing again?
Okay. Yeah, actually I've skipped a bit steps here. Right, now look here. So this step is fine, right? I'm multiplying and dividing by the same number. Okay, so this actually becomes now under root. I can take common. So this is a 1 plus of sine A, or you don't need to take common. Okay, under root 1 plus sine A multiply by under root 1 plus sine A, the same number I have, right? Same bracket, 1 plus sine A, 1 plus sine A. And numerator, you like take whole square root. So you have 1 minus of sine A into 1 plus of sine A, right? Is this clear?
Ma'am, the denominator is not having root.
Yeah, it is having root. This is like full root, right? Okay, you
Yes.
write it like this. Okay, I think the confusion is here. Basically, you do it like this. Wait. This is the original thing given to you, right? So you break the square root first of all. So you write it 1 plus sine A divided by under root 1 minus of sine A, correct?
Yes.
Just separate square roots you have put. Now this is 1 plus of sine A and divided by under root 1 minus of sine A. And then to rationalize, I multiply by 1 plus sine A. And similarly, under root 1 plus of sine A, correct?
Yes, ma'am.
So this will become now 1 plus sine A, 1 plus sine A square root. So the square root will be gone. Only 1 plus sine A will remain in the numerator,
Yes, ma'am.
right? And in the denominator, you have like take the square root, take everything inside square root. So 1 minus sine A into 1 plus of sine A. So this will become 1 plus of sine A divided by under root. Now 1 minus sine A, 1 plus sine A. So 1 square minus of sine square A, correct?
Yes, ma'am.
So that is actually 1 minus sine square A. That becomes your cos square A from the identity. Right? Now the identity is cos square theta plus sine square theta is equal to 1. So cos square theta will become 1 minus of sine square theta. So I put like 1 plus of sine theta and divided by under root. So 1 minus sine square theta becomes your cos square theta. And then the square and square root will actually cancel out. So 1 plus sine theta divided by cos theta.
Okay, ma'am.
Yes, written all of you?
Yes, ma'am.
Okay. Yeah, so please start the next part. Give it a try, all of you.
Ma'am,
Hmm.
ma'am, in the denominator,
Hmm.
1 minus sine A and 1 minus sine, we can use the identity A square minus B square, right?
Yeah, that's what I've used, right? One
So
square.
the whole
Hmm.
root will go, right?
No, no, no. Whole root will go like this. If you have like square root and you have 1 minus of sine A, sorry, whole square if you have, then it will go. It is individually square, right?
Okay, ma'am.
Yeah. So
Yes,
this whole square will actually go with the square root.
okay.
Yes, Rida, Hamna, any confusion? Any step?
No, ma'am.
Okay, please practice it very well. Okay, it requires a lot of practice. Right. Next part, seventh. Now this is a sine of theta and minus of 2 sine cube theta divided by 2 cos of cube theta and minus cos of theta. Okay, so this you have to show this is equal to tan of theta. So let's take the LHS. So LHS, I can see sine theta, I can take common from the LHS, right? So I'm taking sine theta common. So I'm left with 1 minus 2 sine square theta, correct? And similarly, I can take cos of theta common. So I'm left with 2 cos square theta and minus 1. Yes? Okay. Now, see, everything I should get in terms of sine and cos so that I'll be able to simplify. So I'll convert this 1. So this 1 can be written as sine square theta plus cos square theta, right? So I'll write it like this. So sine theta. Now, this 1 I'm writing sine square theta plus cos of square theta and then minus 2 sine square theta. And similarly in the denominator, I can do cos of theta, then 2 cos square theta. Now you have minus, so put a bracket. So sine of square theta and plus cos of square theta, right? Okay. So it will come sine theta into, now sine square theta minus 2 sine square theta. So I'll get minus of sine square theta, correct?
Yes, ma'am.
Okay, so just subtracting. Then denominator, you have cos theta. And yeah, so it will become 2 cos square theta. Then open the bracket. So minus of sine square theta and minus of cos square theta. So that becomes your sine theta into cos square theta minus of sine square theta and divided by, then you have cos theta into, now 2 cos square theta minus cos square theta will become cos square theta and then minus of sine square theta. So this whole bracket actually cancels out. So you are left with only sine theta divided by cos theta, and that is your tan theta, which is your RHS. Yes, written all of you?
Just 1 minute.
Yeah.
Done, ma'am.
Okay. Let's do next question now. Next part is this. The eighth part. Sine of A plus cosec of A whole square. Then you have cos of A and plus sec of A whole square. And you have to show it equal to 7 plus 10 square A plus of cot square A. Okay. Let us start with LHS. Right. So this is A plus B whole square, right? Just open the bracket first of all. So A square plus B square plus 2AB. So that becomes sine square A plus of cosec square A plus 2 sine A into cosec A, correct? And then plus the next bracket. So cos square A plus sec square A plus 2 into cos A into sec A, right? So that becomes your sine square A plus, can I write it like 1 upon cosec square A? I can write 1 upon sine square A, right? And then plus 2 sine A, and then cosec becomes 1 upon sine A plus. So cos square A plus this becomes 1 upon cos square A and plus 2 into cos A. This sec A can be written as 1 upon cos A. Correct so far?
Yes, ma'am.
Okay. Now this sine A cancels out. Similarly, this cos A cancels out, right? Okay. And this sine square A plus cos square A becomes how much? 1. So I'm left with like 1 and plus, then I have 1 upon sine square A, and then plus here I have 2, right? Then plus this cos square A gone. So 1 upon cos square A and plus 2. Is this okay? So
Yes.
basically numbers I'm adding together. So 2 plus 2 plus 1, 5 I have got. Now plus 1 upon sine square A plus 1 upon cos square A. So I think let's take LCM. So I can keep this 5 separate and let us take LCM here. Let me just try what I get. Right. So that becomes your cos square A and plus sine square A, right? And this again gives you 1. So 5 plus 1 upon sine square A cos square A. Yes. Any confusion here?
No, ma'am.
Okay. Now I think I should again take LCM because what will I do now otherwise? No. So this becomes, if I take LCM, like sine square A cos square A, right? So basically I got 5 sine square A cos square A and then plus 1, right? Will it solve my purpose? Hmm. Okay, don't write. Let me just try to solve it, right? Okay, even if I don't want to disturb this 5, let's say, let me keep this 5 as it is, plus. Now 1 upon for tan square A, basically I need sin square A upon cos square A, right? That's what I need. I think I have to multiply it. Please give me time. Let me see what I can do here. So 5 sin square A cos square A, and then plus this one I'm writing as, if I again write it as sin square A plus cos square A. Anyway, we will do it again. Just let me just see what I'm getting. So sin square A cos square A, right? Now, if I divide everything by, let's say I divide everything by cos square A. So I get 5 of square A, and then plus sin square A divided by cos square A will give me tan square A plus 1. Okay. And then I have, yeah, I'm dividing by cos square A, so I only have sin square A. Okay, so this 5 sin square A. So let me keep this tan square A separate. And then again, this one I'm writing as sin square A cos square A. And then divided by sin square A. No. I think I'm stuck with this question. Let me take some different approach here. Let us do it again, right? With some different approach, sorry. Sometimes it happens, you get stuck. Let us start it again. Sin A plus cosec A whole square plus, then I have cos A plus sec A whole square. Okay, let us open the bracket. So that becomes your sin square A plus of cosec square A plus 2 sin A cosec A, right? And then plus cos square A plus sec square A plus 2 cos of A into sec of A, correct? Now this sin square A plus cos square A will give you 1, and plus then you have cosec square A plus, so this will give you 2, I think you know how, and plus then you have sec square A, and again you will get 2. Oh, I think it can be done much simpler. So 5 plus cosec square A and then plus of sec square A, right? So I think I have a relationship between cosec and sec. No, 1 plus cot square A is actually cosec square A, right? And then 1 plus tan square A is your sec square A. Am I right? So
Yes.
I can replace it. Cosec square A, I can write 1 plus cot square A, and sec square A, I can write 1 plus of tan square A. And this gives me 7 plus tan square A plus cot square A. Oh my God, what I did. See, it was so simple. Oh God. Actually, I messed up, I converted this cosec and sec into sine and cos, and it becomes so lengthy. Yes, Rida, Hamna, any confusion?
No, ma'am.
Okay. So let us quickly take the next part, ninth one also. So have you written this one?
1 minute.
Okay, okay. So I'm just writing the question. Cosec A minus of sine A.
Ma'am, 2 sine A and cosec A will get cancelled and 2 will remain, right?
Yes, so because actually I skipped a step because I think I already explained it. So you write cosec A as 1 upon sine A in the next step, and then sine A will get cancelled out. So only 2 will remain. Okay.
Ma'am, so in the next line it would be cos, right?
Sorry, I didn't get Harsh.
Ma'am, so in the next line it would be cos, right?
No, it will not be cos. See, 2 sine of A into cosec of A, right? Now sine and cosec are inverse of each other. So it will become 2 sine A into 1 upon sine A, isn't it?
Yes, ma'am. Like the next term cos. Ma'am, in the next line it would be 1 plus cos A, right?
1 plus. No, this cosec is coming from here, Harsha. The question was sine A plus cosec square A, right? A plus B whole square. So that is your A square. This is your B square. And this is your 2AB, right?
Yes, ma'am.
So this is cosec square A. This is coming from here, B square.
Okay, ma'am.
Yes. And
Ma'am, so
similarly,
sine A and cos A will be 1, right? So like that.
yeah, so basically this is your first square, right? This bracket. And this is your second square, which you have opened. Now, because you have
Yes.
addition in between, so that is why I just removed the bracket. So now this sign will actually combine with this cos, and that will become 1.
Okay, ma'am.
So you can like readjust the terms.
Okay, ma'am.
I'm just doing it very directly. So you can rearrange the terms and then you can show how is this one. Sometimes I skip some steps, so I suppose that you will write it properly. Okay, 2 parts are remaining. Let us quickly take them. So this exercise will be over. Now look at the LHS. So I'm trying to solve the LHS first of all. So cosec A minus sine A. So cosec A can be written as 1 upon sine A and then minus of sine A, right? Similarly, sec A I'm writing 1 upon cos A and minus of cos A. Now take LCM. So it becomes sine of A. So you get 1 minus of sine square A, correct? And here you get 1 minus of cos square A divided by cos A. So this will give you, now 1 minus sine square A is cos square A, right? Divided by sine A. Into 1 minus cos square A is sine square A. This upon cos A. So ultimately you get cos A into sine A, right? Okay, let us try to solve the RHS now. RHS is a bit complicated, so let us solve it. So actually we have another class on this ID, so I have to leave. Let me just quickly